Assalamualaikum and good day everyone. So our topic today is still under chapter number 3. Okay, system of linear equation. So we already learned two type of solution. First, using the elimination method, to be specific, Gauss elimination method, and the second method is using the iteration method, or to be specific is a Gauss-Seidel iteration method. So now we move into the third approach of solving the system of linear equation by using the LU factorization method. So for the LU factorization method, it actually have 5 different methods under this approach. Okay, we have Doolittle, Crowd algorithm, Thomas algorithm, Thomas, and also Kolesky. But for this course, we only cover two method, which is Thomas and Kolesky. And for the rest, it's actually you can learn by yourself if you really understand the concept that used by Thomas and Kolesky. Okay, so the basic concept is similar, and the process of flow of calculation also quite similar. The differences between each method, between this method, is the rules. Okay, the characteristic of the matrix. Okay, for the introduction of LU factorization method, firstly you need to know several what we call as terminology in matrices. Okay, this is a common form of linear equation. Okay, when we talk about a system of linear equation, as you know, we have more than two, at least two, we have more than at least two set of equation, so we can call it as a system. Okay, in this case we have 3 set of equation, for example. Okay, so we can convert the linear equation into the metric form. Okay, so this is the typical linear equation. Okay, if you have 3 sets of equation, we can call as a system of linear equation. We convert into this form. Okay, so this is metric A, 3 times 3, and this is x, okay, referring to this value, and B is the solution on your right side. Okay, now we need to know which what is the lower triangular matrix and what is upper triangular matrix. Okay, this is the metric A. Okay, this is the metric A. So when I talk about the lower triangular matrix, it is actually referring to the lower triangle in the matrix. Okay, so this is what we call as lower triangular matrix. Okay, so we have the value okay, for this, okay, for A11, A21, A31, A22, A32, and A33. Okay, all the what we call as symbol, okay, the coefficient in the triangular, in the lower triangular, have a specific value. Okay, but the rest, it becomes 0. Okay, look at here. Okay, this is the lower triangular. So we write down as L11, L21, L22, okay, L31, L32, and L33. The rest becomes 0. Okay, same with the upper triangular matrix. So the upper triangular matrix is the vice versa. It's actually from the matrix, okay, from the triangle, top triangle, of the matrix. Okay, so this is the upper triangular matrix. Okay, other than that, the value become 0. So the symbol for the upper triangular matrix known as U. Okay, so U11, U12, U13, U22, U23, and U33. Okay, this is very important. You need to know how to recognize and what is the lower triangular matrix and upper triangular matrix to solve using the LU factorization method. So LU here is actually lower and upper. Okay, now we move to the next. Okay, back to the concept. Okay, if you have matrix A, okay, it's actually equals to the L matrix, lower triangular matrix times the upper triangular matrix. So okay, so this is the formula. Okay, A is actually L times U, and at the at the beginning, okay, back to the first one, see, AX equals to B. So if we write down AX equals to B, and we replace A equals to LU. Okay, so we have now LU times X equals to B. Okay, and UX is actually equals to Y. Okay, so we can replace the UX become Y. So now we have new formula or new equation, Ly equals B. Okay, all these equation we will use to solve the system of linear equation using the method of Thomas and also Kolsky. Okay, this is the standard procedure to solve the system of linear equation using the LU factorization method, whether using the Doolittle, Crowd, Thomas algorithm, and also Kolsky. So this is the basic one. So you need to remember this. Okay, you need to remember this step, this three step, because the rest it just depend on the type of matrix, okay, and the rules. But this is the basic or the fundamental of solving system of linear equation using LU factorization method. Okay, now based on this step, we will look into the Thomas method. Let's take a look for an example. Okay, Thomas method, you can refer to page 45, okay, on your textbook. Okay, firstly you need to know what is the rules. Okay, rules for solving system of linear equation using Thomas method. Okay, rules for Thomas. Okay, if you read on page 45, okay, the matrix must be tridiagonal matrix. Okay, you can read on the text there. Okay, a matrix A is a tridiagonal matrix when Aij equals to 0 if I minus j absolute more than 1. What does it mean? Okay, if you still remember, if we write a metric A, let's say metric A is 3 times 3. Okay, this is what we refer as I and J. Okay, the coordinate of matrix. Okay, simply said, we can consider that as a tridiagonal matrix if only three diagonal line have a value. The rest is 0. Okay, for example, we have matrix three times 3, 1 6 0 4 2 7 0 5 3. Okay, only 3 diagonal start with the center, start with the entry, top one and bottom one. Okay, only 3 diagonal have value, the rest must be 0. Okay, if the matrix is not fulfill these rules, we cannot solve using the Thomas method. Okay, let's say if the matrix is 4 times 4 matrix. Okay, you can also refer to the textbook, example on the bottom. Okay, to 6 0 3 6 0 0 to 1. Okay, see here, this is the leading entry, one diagonal line on top one and one the bottom one. Okay, so sorry, this one is 0. Okay, the rest must be 0. If not, if doesn't fulfill these rules, we cannot solve the system of linear equation using the Thomas method. Okay, then the rules for the Thomas method, you can also refer to page 39. Okay, on the bottom one, okay, number 3, Thomas method where diagonal of matrix U is 1. So for the Thomas method, diagonal of matrix U is 1. What does it mean by that statement? Okay, the diagonal of U is 1. Diagonal of matrix U is 1. Okay, and matrix A must be tridiagonal matrix. Okay, these are the two rules. Okay, first is it must be the tridiagonal matrix. Okay, first rules, and the second rules is diagonal of matrix U is equals to 1. So how to solve it? Okay, we back to the standard procedure, standard operation procedure for LU factorization method. Okay, let's rewrite the step. Okay, step 1 is A equals to LU. Step 2, Ly equals to B. Step 3 is ux equals to y. Okay, so we start solving the Thomas method using this step. Okay, let's have an example. Example 3.9. Okay, so we have this set of linear equation. Okay, now first step is step 1. Okay, A equals LU. Okay, now as you know, this is referring to A, this is X, and this is B. Okay, so write down the value for A. Okay, L, so we have L. Still remember, L is referring to the value of low triangular matrix. So we have L11, L12, sorry, L21, L31, L22, L32, L33. The rest is 0. And U. So we have U11, U12, U13, U22, U23, U33. The rest is 0. Okay, so now back to the rules for the Thomas method. Okay, diagonal of matrix U is equals to 1. Okay, what does it mean? Diagonal for matrix U here is referring to this value. This value become 1, so we can write down like here. Okay, we change the diagonal for U become 1, and the rest we can write, to make it easier, we can write it as substitute with ABC, D, E, F, G, H, I, A, G, D, sorry, A, B, A, B, C, A, B, C, D here, okay, D here, E, F, G. Okay, why this one is 0? Because you need to know, to understand, okay, that the metric for Thomas is only considered for tridiagonal. Okay, look at here, this is 0. Okay, so this value here also 0. Okay, now let's mark this one 0, so it becomes 0, and this one 0, and this here become 0. Then we need to multiply the value of L and value of U and equals to the matrix A. To make it easier, we can prepare a tables. Okay. Okay, now we start multiple the value of L and U. Okay. The first row multiple by the first column. Okay, if you still can remember, if we want to multiple the matrix 3 times 3. Okay, so it become A times this one plus 0 plus 0 and 0 plus 0, right? Okay, so this is basic of matrix. Okay, so we got here A times A times 1 is A plus 0 times 0, 0. Okay, plus A plus 0 plus 0. Okay, yeah. Okay, so we got here equals to this one, this value. Okay, equals to 3. Okay, now next, first row times second times multiple the second column. Okay, so we have A times F. Okay, this one, yeah. Okay, plus 0 plus 1, 0 plus 0 plus 0, 0. So equals to 1. Okay. Okay. Now next, so we have actually here A is actually 3. Okay, and then we can replace A, it comes to 3. 3 times F equals to 1. So we got F equals to 1 over 3. Okay, then move to the next. Okay, this one times this. Okay, but we don't need to do for this operation because we already have this value is 0. Okay, this value already is 0. Okay, so I mark this as 0. We don't need to solve that column, that what we call that cell. Okay, and the other one is here. We don't need to solve this. Okay, then we move to the next one is operation of this row multiple this row, so equals to this. Okay, so B times 1 B plus C times 0 0 plus 0 times 0 0 equals to 1. So we also have B equals to 1. Okay, now we move to the next operation. Okay, this row, this row times this column. Okay, so B times F BF plus C plus 0 0 is 0 equals to this value 3. Okay, so we already have B is equals to 1. And we also have f 1 over 3 plus c equals to 3. So solve this, we got c equals to 8 over 3. Okay, you can just using your calculator to solve this fraction. Okay, now move to the next cell. Okay, now we need to times this one and this column to get this value. So b times 0 is 0 plus c times g is cg plus 0 plus minus 0 times 1 0 equals cg. So we already sorry, equals to minus 1 here. Okay, from here minus 1. Okay, so we have already c 8 over 3 times g equals to minus 1. So we got g equals to minus 3 over 8. Okay, then move to the next. Okay, this one times this one. Okay, to got this value. Okay, 0 times f 0, d times 1 is d, e times 0 is 0 equals to minus 1. So we got d is equals minus 1. Okay, then last one. This column, this row times this column. So 0 times 0, we got 0 plus d times g, dg plus e equals to this value 3. So substitute the value of d. We have d here minus 1, g on the top minus 3 over 8 plus e equals to 3. So we got e equals to 21 over 8. Okay, then we already have all this value. Okay, then substitute this value to the actual position. So here is a, replace the value of a here, 3 into a. Okay, rewrite the bottom. Three, 1, 0, 1, 3 minus 1. Just copy for the value of a. Okay, equals to, okay, now you replace the value here with from the tables. Okay, so a is equals to 3. So 3, 0, 0, 1. Okay, b equals to 1, right? Okay, c equals to 8 over 3, 0, 0, d is minus 1, and e is 21 over 8. Okay, same with the u. Okay, so now we have here 1, 0, 0, 1, 0, 1. Okay, so f here take from this f is 1 over 3. Here is maintain 0, and g from the table minus 3 over 8. Okay, so this is A equals to LU. So this is complete for step number 1. We got the value for L, we got the value for U. Okay, move to the step number 2. Is L Y equals to B. So rearrange the matrix. We have L here, from here L, okay, just copy the value of L. Paste. Okay, this is L Y. Okay, so Y, we write down Y as Y1, Y2 and Y3 equals to B. Okay, B, where we can get B value, go back to the top. So the solution is representing the value of B. So we have 1 to 4. One, two, 4. Okay, then solve this equation, turn into a linear equation. Okay, so 3 times y1 plus 0 times y2 plus 0 times y3. So transform this matrix into a set of linear equation. Okay, so we got 3y1 plus 0 plus 0 equals to 1. Okay, then we got the second row minus this y, so 1 y1 plus 8 over 3 y2 plus 0 equals to 2. Then 0 plus minus y2 plus 21 over 8 y3 equals to 4. Okay, so you can solve this. Y1 equals to 1. y1 equals to 1, and y1 equals to 1 over 3. Okay, new from equation 1. Okay, then from equation 2, so we got y1 is 1 over 3 plus 8 over 3 y2 equals 0. Okay, so you solve it, you will get y2 equals to 5 over 8. Okay, then y3, solve this into minus y2 minus 5 over 8 plus 21 over 8 y3 equals 4. So you got y3 equals to 37.5. 0.27 over 21. Okay, so you can also write this value in decimal point, 0.3333. Okay, it's good to practice by writing down 4 decimal point. Okay, 0.6250, and this one 1.7619. Okay, finish for the step number 2. Okay, so move to the step number 3. Okay, what is step number 3 is ux equals to y. Okay, ux equals to y. Okay, where we can get the value for the matrix U is from here. This is the matrix U. Okay, so copy the matrix U. Put right down here. Okay, and x is x1, x2, and x3 equals to y. So y is referring to y1, y2, and y3. So y1 0.3333, y2 is 0.6250, and y3 is 1.7619. Okay, then solve. Before we can solve, okay, we can just solve using back substitution. Okay, similar with the previous matrix. Okay, we can solve this to back substitution. So we already have x3 is equal to 1.7619. Then we going backward, okay, to get the value of x1 and x2. So at the end, you should get the value of x equals to x1 is minus 0.0952, 1.2857, 1.7619. Okay, so you already solved the system of linear equation using the Thomas method.